Alright, this is Mr. Gillum, and today we are going to solve quadratic functions by using square roots. Now, yesterday, the day before, we solved quadratic equations by factoring. Today we're going to use square roots to help us solve equations. Alright, and when you're solving these equations, okay, with quadratics in them, or x squareds in them, then what you're going to do is this. You're going to solve an equation exactly the same as you always solve it. Okay, you're going to get the x by itself. Okay, in this case, it's just going to be an x squared, or a term squared. All right, the opposite of a squared is a square root. So what you're going to do is you're going to take the square root of both sides. Kind of like when you add numbers to both sides or subtract numbers from both sides, or whatever you're doing, dividing by both sides. You can also take the square root of both sides without changing the value of the equation. All right. Something special about when you take the square root of an equation is when you square root both sides, the right-hand side needs to have a plus minus in front of it, whatever you're taking the square root of. It can be a positive value or a negative value, and I'll show you here in a second why that is. Okay, then you're just going to finish solving because you should have your variable alone. All right, so let's take a look here at one. We're going to start with a pretty elementary example here, and it just says z squared minus 7 equals 29. Okay, we want the variable on one side, everything else on the other. Okay, this time the variable just happens to have a squared term on it. Okay, so I'm just going to go about my business the same way as every other equation. I need to get rid of this 7, so I'm going to add 7 to both sides. So z squared equals 36. Now, we're pretty close here. Okay, we need z all by itself. Now, we've been practicing square roots leading up to this point. So the square root, okay, we know this from our difference of two squares, the square root of z squared must be z. So I'm going to take the square root of z squared so I can get a z all by itself, because all we want there is z. I'm going to take the square root of 36 on both sides too. Okay, the square root of z squared is z. The square root of 36 is 6. However, it could be positive 6 or negative 6. I'm going to show you why. If I take 6 squared, I get 36. And if I get negative 6 squared, I get 36. Okay, so really when they taught you square roots way back in the day, they forgot to mention this one little detail. Okay, there's actually two solutions to a square root. Okay, the positive solution and the negative solution. Okay, so you can write it as z equals plus or minus 6, or you could write it as z equals 6 or z equals negative 6. Okay, so there's actually two solutions anyway. And if you recall, okay, when we were solving equations before, say we had z squared plus z equals 0. Okay, we always set them equal to 0. All right, and factored and set each factor equal to 0. Now on these, okay, we're not going to do that. All right, we could have set it equal to 0 and said, let's solve this alternately. Let's say I'm going to set it equal to 0 and factor this. I'm going to subtract 29. Okay, and this is what we did a couple sections ago. So I have z squared minus 36 equals 0. And Mr. Gillum, he told us we could factor from there z minus 6. Z plus 6, because this is actually a difference of two squares. And so I knew my solutions were z minus 6 equals 0 and z plus 6 equals 0. Add 6 to both sides, z equals 6. Subtract 6 from both sides, z equals negative 6. Now, okay, and the same kind of idea up here, if I would have factored it, once I had it set equal to 0, I would have got z equals 0 and z equals negative 1. Okay, so as you can see, you need the plus minus because there really is two solutions that are going to make this true. Okay, there's two solutions that are going to make this true. So please, please, please be very careful. If you forget your plus minus when you square root both sides, you will be missing a solution. Okay, and when we're finding zeros, you'll be missing an x-intercept. Okay, so this is a key step right here, the plus minus. Okay, one more time, we're solving for the squared term. Okay, and we're taking the square root of both sides today. Okay, it's called solving by using a square root. And sometimes it's much more handy than using a the factoring method, because not everything is always going to factor. All right, so let's look at this next one. Okay, this time we have a number in front of our x squared, and what we can do is we can pretend this exponent isn't there. Okay, it doesn't bother us until the very last step. So if it was just 5x, we would divide by 5. That's the same thing I'm going to do right now. I'm going to divide both sides by 5. Okay. And so I'm going to say x squared must equal 16. All right, I'm not done yet because I don't like this 2 up here. I want just x on my left side of my equal sign. So I'm going to square root both sides because I know what the square root of x squared is. It's x. However, the square root of 16 needs to be a plus or a minus 4. Okay, so my two solutions would x equals 4 or x equals negative 4. All right, and I'll show you again. The other day, like I said, we factored to solve, and we set it equal to 0 and factored. If I set 5x squared equals 80 to 0 and factored this thing, I know that at 5 they have in common, x squared minus 16, 0. I can divide both sides by 5 to get rid of the 5 out there. So x squared minus 16 equals 0. X minus 4, x plus 4 equals 0. So x minus 4 equals 0, or x plus 4 equals 0. And as you can see, after all this work I've done, okay, I get my same two solutions, x equals 4 or x equals negative 4. All right, and so you can see the handiness of using a square root. Okay, you get the same answer either way, but what's nice is you can kind of skip a lot of steps. And what we're going to get into here in the near future is completing the square, and that's really going to be helpful, this method of solving. All right, so let's forget about factoring. Let's just go into today's lesson, square rooting both sides. All right, I'm solving for this term so I can take the square root. The first thing I need to do is subtract 5 from both sides. Okay, it's just like a regular equation. 3x squared equals 36. Divide both sides by 3. X squared equals 12. Okay, now this is going to be a little different. Okay, if I square root both sides, x squared equals plus or minus the square root of 12. However, the square root of 12 doesn't have a perfect root, but we can find a perfect root. So what I'm going to do is I'm going to take 12, I'm going to factor tree it. 4 times 3, there's a prime, and 2 times 2. Now remember from the other day, there's a little 2 out there, and that says that for every 2 prime factors inside, you can pull one out. If there's one that doesn't have a pair, you leave it on the inside of the square root. Okay, so what our answer really is, oops, this should just be a regular x. Okay, x equals plus or minus 2 square root of 3, because 2 square roots of 3 is the simplified form of the square root of 12. So I really have x equals 2 square roots of 3, or x equals negative 2 square roots of 3. Okay, that's what that plus or minus is really saying. All right, now let's just take a look just to see, okay, what happens if we factor it. 3x squared plus 5 equals 41. If I subtract 41 from both sides, 3x squared minus 36 equals 0. Take a 3 out, x squared minus 12 equals 0. Okay, so here's what the problem is. Okay, and this is why square roots are so helpful. If I get rid of this 3 out here, divide both sides by 3, then I have x squared minus 12 equals 0. However, I don't know how to solve that. I don't know how to solve it without using the square root. So at the end of the day, knowing how to square root both sides and using the plus minus is essential. You have to know, because not always will the term factor and you will be able to set each factor equal to 0. It doesn't always happen. Okay, so this method is going to help you out of a lot of situations with your equations here.